Yeah, I'm Muki. I'm one of the core maintainers of sbt-native-packager, and today I would like to give you, well, an introduction to native packager. I work at Gute Frage. We use it there as well for various kinds of our production systems. And well, the reason for native packager, of course, is because normally you don't run your application on your local machine, but you want to deploy, create some kind of deployable unit. This can be a zip file that you simply unpack on your target system, a Debian file, MSI package, a Docker image, all kinds of different stuffs. And native packager provides you with the necessary tools to build those. So what I would like to do today is, first I would like to introduce some of the design principles and core concepts of the sbt-native-packager. There are very few, but it's good to know them, and it helps you a lot in understanding sbt-native-packager, how you work with it, how you can configure it, and how you can extend it. I want to start in this talk from a beginner's perspective. We write our documentation for beginners, and I structured this talk as we intend new users how they should learn and dive into sbt-native-packager from the very beginning, where they just want to build a package, to do the more advanced stuff. And this is what I would like to show you in the end. So when we have learned all the core concepts, build a simple package, then we would like to do some advanced stuff. And in this case, we built a new package with Scala Native because it's very simple and it's a nice example. Okay. So let's get started with some of the core design principles. The main thing, this sounds a bit cheesy, ease of use, but SBT doesn't have a history of very low learning curve. And for native packager, we really try to keep the effort you have to put in to get something out very low. So I put the example that you see first on the README. You enable a plugin and then everything works. So this may be magically at the first point, but this is okay if you want to see how things work. And we really try to keep it that simple, so that you have to think about your target system and not about your build configuration. On the contrary, we try to be extensible, and these sometimes conflict with each other, because if you have 1,000 options you can configure, then it's not easy to use. We cover the extensible part mostly with documentation. So for an SBT plugin, I'm very proud that you have a lot of documentation. It still doesn't cover everything, but we try to explain everything that you can extend and can change. And for most of the things, we provide sensible defaults. So you can change things, but if you don't know them and you don't need them, you don't have to care. One of the very core principles is that sbt-native-packager is supposed to build on your native platform. So if you want to build a Debian package, it should build on a Debian platform. Everything on top is a nice feature, but it's not in our very narrow scope of the package of native packager. So you can build a Debian package on a Windows system, because we have a JDEP packaging plugin that enables a Java implementation of Debian, but it's not our core focus to maintain this. So this is all community driven, which is awesome. But if it doesn't work, the chances are high that you have to fix it yourself, open a pull request, and hopefully help others. And the last part are best practices. So to make it easy to use, we try to keep our opinions out of the project and see what are the common best practices. So this includes installation paths on Linux, user and file permissions, and stuff like this. So when you build your package, then everything is like most of the target systems look like, and things just work, okay? So you only have to configure the parts that are different and not that common. So these are the 4 things that make up sbt-native-packager from a design perspective. And archetypes are the thing that get you started quickly. And this is what you see first when you go to the README. Hey, add native packager to your plugins SBT, and then add this line to your build SBT, and you're done. So the Java app packaging is the actual archetype. it configures your build for a specific use case. In this case, a Java application. The name may be a bit off. It should be called maybe a JVM application, because most of you, I guess, will write Scala and not Java code. But it was named that like 8 or 9 years ago, and we kept the naming, and it's okay. So I will do some live coding or live build SBT configuration and show the results directly in the console and what you can do. So I will switch screens up and forth. So this is the slides. Then I have my IntelliJ here, and then down here I have my SBT console. So can you see the very bottom? Okay, nice. Okay, so I've already added this to my plugins SBT. This is native-packager, and I have a simple main file, which is the old one, which simply reads a file and prints it out. Okay, so nothing special here. And what I can do, thanks to IntelliJ, which has a pretty good autocompletion now in SBT, I can look for plugins and I see, okay, Java app packaging is already mentioned, enable it, and I can reload my SBT console. Java app packaging and all related plugins are enabled. And the first task you should be aware of in a native-packager is the stage task. In SBT, you can inspect an existing task, so you get some documentation and explanation. You see it returns a file, and the description is creates a local directory with all the files laid out as they would be in the final distribution. So what the stage task does, I call it with show, so I see the actual directory where it is. It generates a directory with all the contents of my final package. So at the moment I have only a main class and enabled the build as the Java app packaging. And when I take a look at the target universal stage, I'll see the contents. So native-packager created a bin folder with 2 scripts, a shell script for Unix systems and a bat script for Windows systems, and a lib folder where the Scala library resides, and my actual application jar. And this is already working, so I can start this when I call universal stage bin Scala Days with a text file, and my application is executed. Okay, so this is the very first basic thing that SBT native-packager does for you. It creates staging directory where you can do whatever you want with your final application that's runnable. Okay, so pretty simple. So it took us 1 line of SBT and 1 SBT command to get a directory with an executable distribution. An archetype configures all the formats it can handle and enables them. So at the moment we haven't created any deployable unit like a zip file or Debian package. And an archetype decides what formats you can build. And these formats, and this is a big difference in SBT native-packager. We have 2 kind of plugins. We have the archetypes you've seen that define which contents are packaged. That's the content of the staging directory. And then we have format plugins that define what format you can actually build. Okay, and this is one of the most parts that confuses people about native-packager, because we are developers. We go to Google and say, okay, SBT Docker image. Then you come to our Docker plugin page. They enable the Docker plugin, and things don't work out that way, because the Docker plugin only builds Docker images, but doesn't configure a build. So these are all formats. I've already mentioned it: Docker images, zip files, Debian packages, and these formats they are all structured the same way. Every format has its own auto plugin, like a universal plugin that builds zips, Docker plugin for Docker, and every plugin defines its own scope. SBT has 3 scoping axes, so it has a project scope, configuration scope, and task scope. And format plugin defines a configuration scope, so you can scope pre-existing settings to a specific format. For instance, Docker defines a Docker configuration scope, and we reuse the target setting from SBT, which is a folder where you can place target files that get generated, and we scope that to the Docker configuration scope. So you can easily override it, and we don't have to introduce new tasking settings for trivial things that are already pre-existing in SBT. And of course, there are format-specific settings, because every format is a bit different and has some specialties. And we generate the settings, the tasks are prefixed with a format name. So, for instance, the RPM vendor or a Docker base image. So you can identify a format very easily by the prefix. So it's always up front in the Docker plugin or the configuration scope or in the task itself. So you can very easily figure out what things a plugin uses, a specific format plugin. So let's see this in action. I don't have to change anything in my build SBT because the Java app packaging archetype enables all the formats it supports. So all formats are already enabled. So the easiest one is universal, and I'm calling the package bin task. This is predefined by SBT. The normal implementation, so the compile package bin task generates your application jar. And sbt-native-packager reuses the settings to create your distributable package. So when we call it, what it actually does, it creates a staging directory and calls zip on it. So you can actually do that on your own with just the stage command and zip it afterwards. And when you look at the target folder, take a look at universal, you'll see that a zip file is created with exactly the contents of the staging directory. Okay, pretty straightforward. We can do the same thing for Debian. We use the Debian scope, and if you use the auto-completion, you can see all the settings that are defined in the configuration scope. So if you want to dig deeper, just use the auto-completion to guide you through. And of course, there's also a package bin task. And it succeeds, but it gives us a warning. So sorry for that, it's in German. Ubuntu started localizing all error messages, which sometimes kind of weird. But it says maintainer is missing. So somehow there seems to be something missing in our staging directory. And we can actually take a look at what's generated and what is used to build a Debian package. So we call Debian stage, which is the same as stage, but for Debian formats, and it's placed in this directory. So simply in Scala Days target folder, nothing named like Debian. The reason for this is me, because when I started working on this 5 years ago, I messed some things up and I haven't cleaned them up yet. So sorry for that. But in the end, you don't care because in SBT you just reuse the outputs of pre-existing tasks and you actually don't care where they are placed. So we take a look at Scala Days 2018 in the Debian control file, which is used for Debian packages. There are all the metadata for your package. And we can see that the maintainer is indeed empty. And this is what SBT complains about. When we go to the folder here, we can actually run the Debian package command sbt-native-packager executes and get the same error message, hopefully. Oh. So this is the way. Exactly. And we see the maintainer is missing, the error message is coming here as well. And this is what I mean by sbt-native-packager builds on your native platform. It creates a staging directory and executes your native build tool to create the package. So you can easily debug your build by using the stage command and your native build tool that you want to use. And this applies to all. So this applies to Docker, RPM, Debian, etc. So we can easily fix this by setting a maintainer. And I mentioned auto-completion already. Let's take a look. Well, there's a maintainer setting. We write something in there. Save it. Reload and build. And well, let's try Debian package. and the warning went away. So it seems the maintainer is set. We can verify that by calling stage and take a look again at the control file. And as you can see, then the maintainer is now placed in this file. If I want to have different maintainers for RPM and Debian, I would simply scope these to the correct format. And then I would have two different maintainers for two different package outputs. Okay. So this is usually how you work with configuration scopes and how you debug your build. So these formats they form a sort of hierarchy. So at the very top there's universal, and everything in universal is deployable to every system. This is why it's called universal. And everything that's in universal is also in all concrete systems below. So everything you put in universal is in your Docker image, in your Debian package, etc. Okay, and this is where most of the users configure or extend their build if they need to add additional files, because most of you build JVM applications and they run on all these systems. So everything you put there should be deployable on all other systems. There's one exception. For instance, if you have DLL files for Windows or C libraries that are only operate on a specific system, then it's nice to have that you can scope them to a Debian system or RPM or Windows. But this is a more specific use case, which most of us don't have to care about. So universal is most of the time good to go. So speaking about the contents of the package, where do they come from? And there's a very simple concept for that. It's called mappings. It's introduced by SBT. They use it to map the source file, the class files to your jar, and for other stuff, for documentation. And sbt-native-packager uses it as well to say, okay, what content should be put where in your output package? And this is exactly how the API works. So you have a mappings, and you have a tuple. The left-hand side is a source file, which is an actually file that must exist on your disk. This can be produced by some build step, or it's a static file that's already pre-existing. And the second part of the tuple is a string, which is a relative path in your output package. So this mapping here would generate, would put the README file into the root of your package and call it README as well. Most of the time, you will do a native packager something like this. You configure your mappings to a specific format. So in this case, we add something to a universal package, so it will be available in all formats you're building. Okay. Because mappings are such an important concept, native packager comes with a helper class, which is called mappings helper. You can import it, and then you get things like content off and directory off, where you can put in a directory and all the contents will be added as they are on your disk to the mappings. Because it's such a useful concept, there were some SBT plugins importing native packager only for these helpers, which are actually just a wrapper around the path API from SBT. So we added these in SBT 1.x. You can have them for free without native packager. You simply call path, content off, directory off. You have them as well. Because for starters, the path API and Pathfinder API is somehow a bit difficult. So we put these small little helpers in there. So the mappings are very simple. It's a simple sequence of tuples where you have your source file to your destination path, but yet very powerful because you can do whatever you want with it. It's so simple that there are no limits for you. There's a small disclaimer. If you want to configure Linux permissions, it's a bit more complicated. For Linux systems, we have Linux package mappings, which wrap the existing mappings and add the metadata, like which user and which permissions does the user have on this file. Okay, so these are all about the core concepts and how they work together. And the second part is to put them in practice. And to do that, we will build a new archetype from scratch called native app packaging. And we will build some requirements for it. So first, we want to package the existing code I already showed you, but as a Scala native app. So when I create a package, I don't want to create a Java package, but a native package, which contains a native binary I can execute. To make it easier for users, I want to also include a symlink that automatically adds the binary as a symlink to user bin. So when I install my package on a Linux system, I can simply run it from my console, because most Linux systems have the user bin folder in the path environment. And last but not least, we will add a system loader, systemd, to manage our application. So native-packager comes with 3 system loader types: systemd, systemv, and upstart. Upstart is rarely used nowadays because Ubuntu started developing it, I guess, but dropped it for systemd. So there are almost no systems using it or really using it I know about. So most of the systems use either systemv, which is a bunch of bash scripts, or systemd. And so as a developer, I enjoy systemd because it's way simpler. But there are some very religious wars going on what systemd is good for and what not. So, but I'll keep out of that. Okay. So let's start. So we can first we disable the Java app packaging because we want to create a new one. So the first thing we do, we try to configure our build for a basic format. This means we want universal packaging to work. So I want to create a zip file with my Scala native code. And to create Scala native, I need the Scala native plugin. I added it already to the plugins SBT. You need to do a little more setup on your local machine, but you can read it up in the very, very intuitive Scala native documentation. Okay. So I reload my build, and Scala native introduces a new task which is called native link, which generates the binary file. It generates the file in target Scala Days 2018 out, and I can still run it. So that's the same application, but now as a self-contained binary. When I call stage at this point, it's super fast because it actually does nothing. When I take a look at the stage folder, or try to, it says, well, there's no file. Because when I take a look at my mappings in Universal, they are empty. So I enable the Universal plugin format, but the plugin itself doesn't configure anything in your build. It just adds its configuration scope, configures all the settings it provides itself, but it doesn't touch your mappings, because that's not part of what a format plugin does. That's what an archetype does. And this is what we do now. So we add to our universal mappings, we map the output of the native link command. We scope it to compile, because this is a runtime artifact we want to generate, and we put it in our output package. We want to put it in a bin folder as well. This is once it's best practice. You see it in most of the distributions you get, and we will also see later that it's required for systemd to work. And this is the part now where you see how we try to make everything extensible in a native packager. What should be the name of the output of our binary? And there's a task for it, or a setting called executable script name, and we use that. So the setting is derived from your project name, which is a sensible default. But if you like to override it at some place, you simply override the setting, and all the other places that need the executable script name will automatically point to the right script name. Okay. So this is all. Now we added our binary to our package, and with a sensible path, we reload. And let's take a look at the universal mappings. You see that the compilation step is happening now. And there's one mapping added, which is our output file to bin Scala Days. So let's try stage again, which exactly does the same thing because it depends on the mappings, and the mappings depend on the native link. And now we get this output. So we have our staging directory, which has a binary which I can execute, which is the same as we saw before when we simply called native link. Okay, so this was part one, packaging our existing code with Scala Native. So it took us 2 lines of SBT to get there, which is pretty okay. You could hardcode the executable name yourself. This is totally fine, but it's easier in the next steps if we use a setting for this. And now we do the Linux symlinking part, and because symlink only makes sense on a Linux system, we support another format, and in this case the Debian plugin. Because I have a Ubuntu machine and I create a Debian package I can easily install, and so we can verify that that works. Because at the moment I can't really call anything on Debian. You see, there's only the maintainer I've configured at the top, but nothing else. And now when I reload, because I enable the Debian plugin, there's a bunch more tasks and settings already configured. And I can build my Debian package now, which contains the native our native code. Okay, so now let's add the symlink, and we can try to find a sensible setting by starting with Linux. And there's already a task key called Linux package symlinks, which looks pretty promising. There's a list of symlinks, and we want to add a symlink for it. And to do that, we need to import the required case class. So as you can see, native-packager is pretty old. We haven't switched to lightband yet. Well, it's fine. So every format has its own package as well. In this case, Linux, and there's our Linux symlink case class. So we add a Linux symlink to our output, and we have 2 strings. So first is the link, and the second is the destination. So the link is the actual thing that gets placed on disk and that points to the destination. This is pretty straightforward because we want it in user bin, and well, it makes sense to give it the same name as our executable in our package. Okay, so we reuse the executable script name. So if we change the setting somewhere or another user, things will still work and still look the same. So the destination is a bit more complicated, and this is where you see that native-packager is very old, and we really try to not break your builds by changing settings and removing them and refactoring like we want to. And the first thing is the destination, so we need to know where is the package actually installed. And of course, there's a setting for it, and we search for installation, and we find default Linux installation. And as you may notice, it starts with default and not with Linux. So it should be called Linux default installation location, so you can easily figure out that it's a setting from the Linux plugin, but we haven't refactored that yet to keep your builds intact. But this is the root directory where your package is installed. Okay. The package itself needs a directory in your default installation location, and there's yet another setting which is called package name, which can be used for various kind of metadata. So if you want to install your package via package manager, then you have the package name there. In the end, the default value is derived from name, so everything is called Scala Days. but you can pick specific parts of your build if you like to and configure it, because you don't care about the executable script name maybe, but your company has some naming conventions on how packages should be named. So you can just configure that small part and leave the rest as is, and you don't blow up your whole SBT build with tons of configuration, but only the parts you really care about. And then we are now in the actual staging folder. So what's gets packaged as your application, and then we are in binary, executable script name, and having the value. So we created a symlink from user bin to the default installation where the package is placed, and then to the actual content. Okay. So we reload SBT, rebuild our package, and then let's see. So I planned this for 10 fingers, and passwords are really hard with 9 fingers if you have like muscle memory. But yeah, worked out. Okay. So as you can see, Native Packager, the Debian plugin, adds some infrastructure around. So it creates a system group and a system user, which are again both settings, daemon user and daemon group, which you can customize if you like. They don't get a shell. And I can call now Scala Days directly from my CLI. So the symlinking seemed to work, which is nice. And I purge it, so things are removed. And when I now try to call Scala Days, it can't find the binary anymore. So we added a symlink in 4 lines of SBT, which is pretty nice, I guess. So now we have the last part. We want to manage our application with systemd. And this is only 1 line. Because we've done all the previous work, we only add the systemd plugin, and we're done. So this was one of the major refactorings we did last year. We split up all the system loader into separate auto plugins and removed them out of the Java Server App Packaging plugin, which formerly controlled all these things. But now you can use these system loaders separately and can more easily combine them with other packaging plugins, which is kind of nice. I also add the main method. I also changed the main method, so it runs forever. So there's a while true loop. You did not see that. And when I now build my Debian package, a bit more is generated. We can see that when we install our package. Yep. So when I call system control, I should have reloaded first, right? Yeah. So clean it. Because when you install the package, you'll see that there's a new symlink generated for systemd, where the systemd configuration file, which is named Scala Days 2018 service, is placed. And we can now take a look in our application with systemd. We can also stop it and start it like you're used to. So now it's stopped, and you can start it again. And when you take a look, it's running again. So pretty straightforward. So I mentioned the bin here is very important. Everything in the systemd script is configurable, other than this small folder. This was hard coded by me, and but nobody has complained so far, because most of the packages have a bin folder where they put their binaries, and so it just works. This is where we try to. This is some kind of these best practices, we try to put into native packager. So even when you can't configure it, most of the users don't notice it because all systems do that way, and there's no need to configure it, okay? And if you want to configure it, it's pretty easy to, well, make it so. Okay. So, I would like to sum the things up we did today. This was a very straight tour from, well, this is native packager from the beginning to the end, to do some more advanced stuff. So I already mentioned it during the talk. There are two types of auto plugins, and this is a continuous story for years now that people confuse these two. There are these archetypes and the format plugins, and the archetypes do the really heavy lifting but aren't magic. So they configure your build for a specific use case. The Java app packaging is actually much like the native packaging that we just built. The only difference is that it figures out your class path. So this is some SBT magic. What library dependencies do you have? But in the end, it puts them in the mappings under the lib folder. And this figuring out, it's not a lot of code, but you have to know some of the SBT internals for that. But that has already been done. So it's nothing scary. It's a simple configuration. Formats are the ones who provide scopes and prefixes. So usually archetypes don't add a lot of additional settings, only if they need to be configurable in some way. And as you've seen, so watch out for inconsistencies if you don't want to do more deep stuff in native packager, configure more aspects of your build or create your own archetypes. Not everything is very clean. We're happy to accept pull requests. So we got a lot of pull requests fixing documentation, which is pretty awesome, ranging from wrong documentation, outdated documentation to simple spelling and grammar fixes, which is kind of nice because documentation should not only be correct but also enjoyable to read, and less grammar mistakes and spellings make it easier. The second main concept were the mappings, and these are the foundation for every package. So this is actually native packager are these mappings, because the formats itself, you could call the command line yourself in an SBT task. You could implement that in 2 or 3 lines SBT yourself. You simply need these mappings put somewhere in a directory, and then you call the Debian packaging build tool, for instance, or you create a Docker file and put your mapping somewhere and then execute Docker publish. So this is a very core part, and they are so simple and easy to use because it's only a list from files to destinations that you can do everything that you are used to do with lists. You can filter them, do regex magic on the paths if you like. You can move stuff around, add new things. You're free to do with anything what you liked. The only where it gets a bit more complicated is for Linux, because we need to wrap them to add the additional metadata. But most of the time you don't care about the Linux package mappings, because we provide sensible defaults for all of the mappings you add, and usually it's fine. You don't need to add anything. And for Docker, for instance, you have it isolated in a container. That doesn't matter that much as well. And the last part is documentation. So I already mentioned we write a lot of documentation. I have an examples GitHub repository with 15 or 20 projects with only a specific small use case, how you can do that. But we really appreciate if you write more documentations and provide pull requests which add simple examples. We have a recipes section where you can simply dump a small use case you had and simply add them. So, and this is how some of the other archetypes started out. So for instance, we have a launcher and a class path jar archetype, which change your build in a way that a single jar is created that contains a manifest file with all your class path, and that is actually executed at runtime. This is a workaround for long class paths, which is especially on Windows a problem. And we started out to, okay, you can do this by copying this in your build SBT, and it eventually was implemented, I think, by one of the Play contributors, and put into native packager. The same way was for the Ash script plugin. So if you have a Docker image and you use an Alpine base image, then you can enable the Ash script plugin, which switches out the bash scripts to Ash scripts, and you can reduce your Docker image size. So yeah, we need more. Happy to accept and happy to have all your additions to native packager. Okay. So that was the whirlwind tour through native packager. I'm ready for questions. You can speak up. I repeat the question. Okay, there were two questions. So first, man pages. How do we support man pages in native packager? The answer is very short. At this moment, we don't. I'm not aware of that. There's some kind of feature we have for the universal packaging. We have a source universal packaging and the docs universal packaging, where you can create like zip files with your documentation and zip files with your source files, but not for Linux man pages. And I think there was a request a few years ago, but there wasn't any traction on that. The second question was systemd. How can you configure systemd? So there's system loaders. There's a top level system loaders plugin which provides some default configuration settings, like where's the start script and a timeout and should it restart and stuff like this. So you can simply configure these settings. And for systemd, I think there's one or two special settings. So what is the success exit code, I think, because you can say, well, one is a successful exit code for systemd as well. So it doesn't say, oh, I tried to restart, but actually it's okay. And if you can't, so if there isn't any setting that you can configure for use case, then simply open a pull request. The current mechanism for how we build those templates is handmade. This is one thing we want to refactor, because at the moment we have a big map from and we do string replace in the end. So you have a map of a key and it maps to some kind of value, and then we get our template and then we replace everything that's in these maps. So we don't have the ability to nest specific templates or have recursive stuff so that you replace a variable with another variable. It's very simple, which makes it easy to debug, which is a good thing, but there are some limitations. And in the end, you add these settings, add it to these maps of replacements, and then you add the placeholder in the script. So it's very straightforward. Any Docker questions? I've left out the Docker image example because it's trivial as well, but usually people ask about Docker. Okay, that's cool. Anybody using Docker in production? Okay. You're using a native packager for doing so? Okay, so the others use sbt docker, I guess? Okay, only two. So the rest of you doing custom stuff? Okay. Cool. Then, thanks again and enjoy the evening.